was placed in the first group in the periodic table, which is the group was calculated from left to right. Element group 1 was also known as alkali metal due to this element will react with water to form an alkali and hydrogen. Elements of group 1 are lithium, sodium, potassium, rubidium, cesium, and francium. Group 1 alkali metal have one outer level electron and have high tendency to lose its outer shell electron to form positive ion with positive 1 charge. Alkali metal also is a very reactive metal. Next, the trend as we go down the group is increase in reactivity, atomic radius, electron shell shielding the outer electron or known as shielding effect, and high tendency to lose its outer electron to form a positive ion. As we go down the group, the melting and boiling point of alkali metal will decrease but increasing in density of water. Next, anomaly of lithium, which is special character compared to the other alkali metal element. It is due to its small ionic radius and tendency to exhibit covalent bonding due to high polarizing power and high charge density. Lithium is the only element which form normal oxide when heated in oxygen, form nitrate when heated in nitrogen, and form carbide when heated in graphite. Lithium nitrate also will decompose directly to oxide, and lithium hydride very stable and can heating up to 900 degrees Celsius. Last but not least, diagonal relationship between lithium and magnesium, which is these two elements have similar character in chemical properties. It is due to similar in atomic size and electronegativity and tendency to exhibit covalent bonding. Lithium and magnesium are the only element which form normal oxide when heated with oxygen, form nitrate heated with nitrogen, and form carbide when heated with graphite. Carbonate of lithium and magnesium will decompose to carbon dioxide and oxide, while nitrate will decompose to oxide, nitrogen dioxide, and oxygen when heated. The sulfate and carbonic salt of these two elements are insoluble in water.
Assalamualaikum warahmatullahi wabarakatuh. My name is Saif Aiman. So I will present about the compound of alkali metal, which is hydrides, oxide, and also nitrates. Okay, so first is hydride. So this is a preparation of hydride. First, metal from group 1 or group 2 react with hydrogen gas, will produce silane hydride. The second one is metal oxide from group 1 react with hydrogen gas, we produce metal hydride and also metal hydroxide. Okay, next is reaction. First, hydride react violently with water. So you can see this is a general equation for reaction of water. So we produce metal hydroxide and also hydrogen gas. So the second one is reaction with alcohol, we produce alcoholic. So same here, this is a general equation. So this is alcohol and this is alcoholic. And the third is reaction with liquid ammonia will produce amide. So metal hydride react with liquid ammonia NH3 and produce amide and also hydrogen gas. So the fourth is reaction with oxygen will produce oxide. So this is oxygen and this is oxide formula M2O. And also same will produce hydrogen gas. So this is a uses of hydride. First one is reducing agent. So we have a two lithium aluminum hydrides and also sodium borohydride. So the second one is more selective because it does not reduce C double bond C. So next is as a fuel. Lithium deuteride is used in nuclear fusions. So the last one is source of hydrogen gas. As we know that this is a general equation, so we can see the product is hydrogen gas here. So this is oxide. So we have a three type: monoxide, peroxide, and also superoxide. So how we prepare it? for monoxide, we need a metal react with metal nitrates to produce monoxide and also nitrogen gas. So we need a heating process, and metal we use potassium, rubidium and cesium. Second, peroxide M2O2 diamagnetic structure. We have two ways here. So the first one is using sodium react with oxygen gas, we produce peroxide, but we need to know the temperature is 300 degrees Celsius. So the second one is using potassium in ammonium liquid react with oxygen, will produce peroxides in 50 degrees Celsius as a temperature. So the last one is superoxide MO2 paramagnetic structure. So we have two ways. First one is metal react with oxygen will produce superoxide, but metal we use potassium, rubidium and cesium, and the temperature is 300 degrees Celsius. And the last way is using sodium react with oxygen will produce superoxide, but the temperature is 500 degrees Celsius. So next is reaction with water. First, monoxide react with water will produce metal ion and also hydroxide ion. So peroxide we have two condition here, which is a 0 degrees Celsius and room temperature. So for 0 degrees Celsius we will produce metal hydroxide and hydrogen peroxide, but for room temperature we produce metal hydroxide and oxygen gas. For the last is superoxide react with water will produce metal hydroxide and oxygen gas. So next is uses of oxide. So first one is sodium peroxide octahydrates produce H2O2 as bleaching agent for hair, flour, fiber and also fat. Second one is superoxide KO2 to get rid of carbon dioxide and to produce oxygen in a closed area. So next compound is nitrates, for example sodium nitrates and potassium nitrates. So for sodium nitrates is delication solids used in making other nitrates, fertilizer and explosives. For potassium nitrates, naturally occurs as mineral saltpeter used in manufacturing explosive, fireworks, matches and also fertilizer. So here is supportive question. So first, between lithium aluminum hydride and sodium borohydride, which one is more selective reducing agent? The answer is sodium borohydride, because it does not reduce C double bond C. So the second one is what is structure of peroxide and superoxide. So the structure of peroxide is diamagnetic structure and superoxide is paramagnetic structure.
Hi, today I will be presenting to you the compounds of alkali metals. Specifically, we're going to discuss about hydroxide and carbonates compounds of group 1 metals. First, we're going to see how to prepare sodium hydroxide and potassium hydroxide in an industrial process, which is electrolysis, which consists of Kellner's-Solvay cell. The reaction that took place at the anode of this cell is Cl- being oxidized to Cl2 and Na+ being reduced to Na. Next, Na dissolves in the liquid mercury to form an amalgam, which is removed to the decomposer. In the decomposer, the amalgam reacts with water to produce sodium hydroxide, hydrogen gas and mercury. Sodium hydroxide being widely used to manufacture synthetic fibers, soaps and detergents. It is also used to obtain pure Al2O3 from bauxite through Bayer process. It is also used to separate phenol and cresol from coal tar. It is also act as an bleaching agent in pulp, rayon and textile industries. Potassium hydroxide, on the other hand, used as an electrolyte in the manufacture of nickel and iron battery. this slide, we will discuss about how to prepare, properties, and the application of potassium carbonate. We have to use the electrolysis of potassium chloride solution, and then the resulting potassium hydroxide is then carbonated using carbon dioxide to form potassium carbonate. The properties of the potassium carbonate is it is white in color, very soluble in water. It acts as an flame retardant, which causes its application to use as a fire extinguisher. Another application of the potassium carbonate is it used to separate alcohol and water. Solubility of alcohol become less in water. This process is called salting out. Next, we're going to discuss about how to prepare and the properties of hydrogen carbonates of group 1 metals. To prepare alkali metals hydrogen carbonates, we have to pass through carbon dioxide gas in a saturated Na2CO3 solution. Why? Because NaHCO3 is less soluble than Na2CO3. The properties of the hydrogen carbonates of group 1 metal is that they have a low thermal stability, which means they decompose upon heating.
Next, some application of alkali metal elements. Lithium always used as reducing agent for organic compound and produce hydrogen. Lithium also one of the component in alloy due to low mass and density. Sodium usually produce yellow glow, so it used in street light or lamp. Other than that, sodium alloy is used as coolant in reactor nuclear. Potassium is used to produce KOH for production of soft liquid soap, while KCl and KNO3 used as fertilizer. KNO3 and KClO4 also used to make firewood because nitrate and chloride is a very strong oxidizing agent. Next, let's move to application or uses of compound of alkali metal elements. For hydride, they are usually used as reducing agent producing H2. NaBH4 is more selective reducing agent than LiAlH4 because it does not reduce carbon double bond. It also used as source of hydrogen gas and as fuel. Next, for peroxide, sodium peroxide octahydride used as bleaching agent, for example, for hair, fiber, or fat. Superoxide is used to get rid of CO2 and produce O2 in a closed area, such as in mine, space shuttle, and submarine. For hydroxide compound, for example, NaOH is widely used in the manufacture of synthetic fiber, soap, and detergent. Other example is KOH, where widely used as an electrolyte in the manufacture of Fe and I battery. For carbonate compound, some of example application is for NaCO3. It is used in manufacture of sodium silicates, water glass, and in manufacturing of soap and detergent. While K2CO3 is used for the preparation of soap, animal wool cleaning, drying agent for organic liquid or solvent, and in manufacturing glass and ceramics. That's all. Thank you.